Hello and welcome. I'm Bill Wake. We're here working on the Elm interpreter. We've made a bit of progress. Yesterday we finally got recursive functions working, which now I'm looking back, I wish we'd worked on sooner. But when we look at the parser, there's still a lot of error handling and semantic stuff going on that kind of obscures the parsing a bit. So I'd like to focus on the parser today and improve things there. I saw a couple other things we might take a look at too, but I think that'll get us going for the day. All right. And let's see, I believe I ran tests. Yes, so the tests are all green. That's good. And let me find an example of what I'm talking about. Let's make sure our to-do is okay. Yeah, we'll just break that down a little. Okay, so consider whether throws would be better than returning a tuple for the parser function definition, pre-declare function, and enforce prototype. Make future tuple get comma work. Okay. Let's see. So the parser. Well, this is what I've called this adequate. So it's recursive descent. So you have a grammar rule, and the name on the left becomes the function name, and then the series of things on the right become code. And if it's a function, or if it's a reference to a left-hand side, then we call that function operator expression here. And if it's a token, we just match it. And if it's meta syntax like 0 or 1, we have to decide whether or not to do it. Okay. And so this one's a fairly straightforward mapping. Operator expression gets called, some error handling. We look for equals. If it's there, we create a function definition, and otherwise we just return the original expression. So that has a little bit of semantics leaking out. So you can see we're returning something rather than just calling parse on it. Okay, and that's because we're building up expressions. You can also see some error handling here. All right, but all in all, that's not too much imposition on our grammar rules. Okay, and we're going to keep going. Here's function definition, the rest of the right-hand side. You've got the equals. You got to skip over that, get next token. Then we're going to do some pre-declare function to allow recursion. So if you are defining a function, you are allowed to call it recursively. So we need to put something in place so that we know the function has these arguments and so on. So we did that last time. That's what made our recursion work. And we do a little more error handling, another call like that. And then we got this. Wow. That's all semantic stuff. All right. And I guess the definition too. So given you've done all the parsing and you've gathered all the information, then we're going to turn this function declaration into a lambda expression and then plop that in as part of the definition. All right. And that's the sort of thing I'm talking about that is semantics that's kind of hiding the parsing. So if you look at the parsing side, it's a list of variables, which we've already got, equals, and then operator expression. So we're skipping over the equals. I guess this is really more like, I don't know. I was trying to show some context, but we skip over the equals and then we call operator expression. Everything else is semantics and obscures the parsing. But I don't know. I could do better on this. I think this is really like, yeah, that's the context. And then we got function definition equals followed by operator expression. Okay, that's what we're trying to parse in here. Skip over the equals. We already know it's there, and parse the operator expression. Okay, and the rest is semantics. And here's pre-declare function, more semantics, and all this stuff about errors, and that's the part I'm interested in fixing. Then enforce function prototype is called by that. That's also semantic stuff and also deals with errors. All right, and then we're back into the main grammar, operator expression, you parse an expressions, which is potentially a function call. Maybe I should clarify that with the name a little bit. Then you have a series of operators and expressions. So 3 plus 2 times 5 minus 7 and so on. And then some semantics, including, well, there's the rest of the parsing, because our precedence parser actually enforces priorities, associativity and stuff like that. All right. And then more expressions with more semantics. All right. This one is just the pieces is a little bit of error stuff, but not bad. And then down here, we have these multiple levels of expression. So you get a parenthesized expressions, which could be tuples, and again, some error handling. Okay. And so on through the rest of the syntax, lambdas, ifs, whatever. Okay. Let's find a good place to start. Oh, I should say the other thing I noticed this morning. We have the symbol table, which is where we're going to put the functions and possibly the names, like when you evaluate a lambda expression, lambda n goes to some function of n ends up in the symbol table for evaluation. But we have these predefined custom types, Booleans, and false and true. They're kept in their own structure. That really should be in the symbol table. We'd like one structure that defines all the stuff at a scope and one consistent place to look. All right. Let's go to to-do and see what we said yesterday. For parser, function definition, pretty clear, and enforce. Basically, we want to talk about throws. And I don't know. I thought Java's distinction between errors you have to catch and errors you don't have to catch, it may have seemed like a good idea when they did it, but I think it turned out poorly in practice. And then Swift kind of adopted a similar approach that you have to explicitly declare throws and all that, and it means there's a little bit of syntax overhead that I don't particularly care for, but that's the way it goes. All right, so what we've done, and I don't know, it's a little awkward, but we've basically said when you return the result of this pre-declared function thing, we're either going to get back a function prototype, which we can, like function ABC, which we can use to define the function, or we're going to get back an error. And the convention here is like either prototype could be empty and error not empty, or prototype could be full of variables and error is nil. And then we have to return nil from that. Okay, and return the error. Let's go down here. Where's the error coming from? Well, that's coming from further down. And you see we end up catching it along the way. So enforce function prototype actually creates an error expression for us. But yeah, so it creates the error expression. Then this level has to check, did you get an error? And then this level has to check, did you get an error? So we end up passing the buck, throwing the thing further and further up, and until finally somebody checks and says, oh wait, there is an error, I should do something about it. Or they just doesn't go. So let's see. So library expressions, yeah, that's sort of their attitude in Java, and Swift to some extent. But in day-to-day Swift, I don't run into it unless it's sort of self-inflicted. Java, you hit it a lot. But yeah, okay. So we're gonna try switching it over to try catch and throws, and basically the easy way to do that is going to be start at the bottom. So enforce function prototype is the thing that does this. Now I don't remember in Swift. I think you have to make an error class that you're going to throw. I don't think you can just throw error expression, but we'll give it a shot. All right. So what you have to do is say throws. And I don't think it's going to make us do a try catch when we're the one throwing. So what I want to do is I want to, let's see, they should be complaining. Okay, here we go. Yeah. Call can throw, but is not marked with try. Okay, so let's do a try, and then we have to do a catch. So I think it's do. Are you gonna? Yeah, I can borrow theirs. Okay, so try throwing expression. That's this. And I'm going to keep this same stuff for now as well, but we'll get rid of it at some point. Okay, so the pattern is, well, I don't know if I can catch an error expression. Yeah, I'm going to have to look. Yeah, this is what I was afraid I had to do, is create my own extension of enum. I mean, of error. Yeah, let's do that. Okay, so we'll just put that up here. Oh, I've already got an example parser error. Well, let's continue that then. This is a what do we got? Well, I guess I want to get something going. I'll just I think I'll just start with this, but yeah, that's probably okay because I got to have the location. I would like the location for reporting purposes. So this will be, we'll just call it an error expression. And then it takes an error expression. I don't think I have to. No, I do have to give it a name. Okay. Let's see. We'll just reuse that word all over the place. Okay. And I guess I can probably do that. All right. So find our try catch. So now I can say catch dot error expression let error. Okay. All right. So what's going on here? Here's something over here. Well, I don't want to deal with this. Well, I'm. Oh boy. Can't find prototype in scope. Ugh. I'm using the word error too much too, aren't I? Just to try and get this thing going straight. prototype can't be used there. That's unfortunate. Well, maybe I should just do everything in here, in the main body. I should have wrapped further. So I'm just copying the original body inside the do catch, and we need to return something in these cases. So if there's an error, just to follow our existing convention, I'm going to do this: return the value with the error expression in there, the error. Okay. And in this case, this is an unexpected situation because I'm not going to throw anything else, but I've got to have something. So let's make an error expression. The message is error messages dot cannot happen, and that should be fine. Okay. So all I've done for all the whining, I put throws on here, and then I made this function prepared to handle the throw. All right. That should be a no op. Let's check it. And in fact, nobody's calling this case right now. All right. Okay. So now what I want to do is, in this case, instead of returning the prototype, I would like to do the throw. And let's try it. Throw. And this is going to be error dot. Whoops. Parse error dot error expression, and the error expression is this. I guess I can leave it on the line like that, and yeah. Okay, so my hope is that if you don't find all variables, like if somebody said function of A7C equals this, you'd be like, no, you got to have names for the prototype. Okay, so if I don't find the prototype, all variables, then I'm going to throw an exception. Instead of catching this case, instead of catching it here, I'm catching it here, and I'm returning whatever the error is. So if I got an error back, I'm returning it, and now I'm throwing to get the error. So I believe this should be the same. All right. Sometimes that 1.1 seconds is rather slow. Okay. So I am successful here. Now I don't need, nobody's returning back. Let's see, what are they returning? Well, they're always returning nil. There's no other return in here. Okay, so I'm going to modify this type to just return variable. All right, and then this comes off. All right, that should be fine. Now the caller is not ready to deal with that. Okay, so he expects this. He should just get the prototype back. Is that. Okay, now there is no error anymore, so there's none to be nil. And that. And what have I done? I was just catching up. Okay, so let's see the whole thing now. Prototype, we try and enforce the function prototype as all variables. If it is, we drop the first reduce. I mean, this could be a little better. We get the type, basically. Yeah, that's a little confusing, but it's getting the type. We'll work on that now. This, and then otherwise, if we get an error, we return it. All right, now I want to do the same process. So, you know, I probably could have skipped it through, but just trying to kind of do things a little bit at a time, I guess. So let's put this where it goes. So we want to make this throws. Okay, so pre-declaring a function will now do a throw. Well, can I bubble that out pretty easily? So if the called function throws, we want this one to throw. So I think we can just do this. Well, do I have to do that yet? Let's see. Let's make the caller deal with it. We've got that same issue. Okay, so I think again this stuff. Well, I can do the whole thing up here again, I think. I'll put the body. We may get some other stuff out of this. So that becomes this. And we need to say try on the thing that can throw. On that. And then we're going to have to do something very similar to this at the end. We either get a parser and we handle it. Any expression to result type. What's the result type? Oh, the result type is expression. Okay, so here, if we get the expression, well, we're trying to return just the error. Okay, so, oops. What? I hate the way they have these keys tuned. So skip a word skips over all the punctuation. It's just not what you want when you're editing this stuff. And same thing here anyway. We just need an error expression to return because that's the whole deal. Okay, and notice the one we're throwing from our inner thing is going to be the same one that we would return here. All right, again, I think this should be neutral. And then we can try and get rid of the stuff down the bottom. Now, I don't know how it handles. If I have a throws method with a try call, I'm hopeful I don't have to do this anymore. Okay. Oh, I'm still building. Okay. Right with this now. So I'm taking the do catch out. I'm hoping try was allowed to just do a throws and bubble it out. Because that's the part I really hated in the old design, so I'd like to get rid of that. I mentioned Go yesterday. That at least used to be Go's way of handling exceptions too. Every level had to deal with it. Yuck. Okay, it's testing, so it liked the syntax. Okay, so good. All right. So if we get the error at the lower level, we just bubble it through. I like that. All right, and this, the body is in the do, and then the exceptions anywhere along the way, catch it and continue. That's nice. All right, now let's take the same thing on this. Notice we have one return. It returns nil. We don't need that now. Okay, and this can just be variable, list of variables, and that. All right, and our caller's got to deal with it. Prototype comes back, and this takes care of that. All right, not too horrible. Error can't happen now because we always just throw, and there is no error. Well, the only error is down here. Okay, and let's make sure here. I guess I'll have to put this in the bucket of should have been done earlier, I guess. All right, now the function definition, if something comes back with an error expression, well, from the operator, it returns it. If the function definition returns returns an error, then it returns it. So this is, at least for now, the top level we need to do a do catch on as far as we go. Now this error expression cannot happen. That's a little annoying. Let's find usages of this. Oops. Callers. No. Elm-type.error. We don't care about that one. Parse-error.error expression. That's us. I don't think. Oh, there it is. Parse-error.error. Require. Let's find require. Okay, we do. Well, yeah, we're getting more of these things. Again, it does force some of this. It's sort of half checked. Well, what I hate is having to put that extra wrapper around, catch the default case, which I know is not going to happen in those situations. If condition not Boolean, let's find that one. Well, that's all sort of the stuff that goes wrong with the if statements. And he's got to do the unknown catch too. Well, I don't think it's terrible to have the if semantics like this. I don't know. It's a little wide for the. I'll hide your comments for a moment. All right, so if the type is not Boolean, throw that. I don't think that would hurt to look like that. And if the type is error, throw that. Okay, I mean, that seems to be going after the two things that we care about for if statements. Yeah, maybe we're okay. A little extra catching at the top level, higher levels isn't terrible. Okay, let's go down top to bottom. Okay, so parse is you got you're looking for either an end of file where you're done, a lowercase name, which is starting a function call, or some sort of other start to an expression. I guess this seems redundant. if the token, I would think, let's see if can start expression contains lowercase name, because they're both calling the same thing. Lowercase name, yes. So that's a redundant thing. Let's go back. So this case, I believe, is totally redundant because token can start expression is true here. So, yeah, all right. Let's see if that works. I know I did something a little different before. I think maybe we enumerated the cases here or something like that, but this is kind of simplistic. Okay, so either you're an end of file, in which case we're done, or you start an expression, and is everything all right there? Okay, or you start an expression and you're a function call or definition. All right, so that can go. All right, let's commit. I guess we've got make function definition use throws instead of passing back a tuple with prototypes and error. And we deleted redundant case at top level parse. All right. This lookup custom value, okay, that's making up for the fact that we don't have our variables, our true and false in the symbol table. Also repetitive. Okay, we were here. This seems okay. Then it calls function definition, and if it's not happy, it returns an error expression directly. Okay. Let's work on. We got this. What is this doing? I'd like to get the name. You know, there's this notion of keeping things at the same level of discourse. So composed method is the name of that pattern. It's one Kent Beck called out a few, I was going to say a few years, but probably 2 or 3 decades ago at this point. You know, it was originally in a small talk pattern in his Small Talk Best Practice Patterns book, which is pretty old. We all get older. But at any rate, the idea is keep everything at the same level of discourse. And this is tolerable up here, but then this is like, wait, what? You know, what's going on? And so let's see what we have to do here. And I use extract method as like a data analysis, but the challenge is Swift is really bad at I should say Xcode. It seems to me like variable value, that's coming from the arguments here. Reduce is coming from here. All this is coming from prototype. I believe I can just make a method like this. So let's put it down here. This is well, I'll just call it foo for the moment, and we're just going to get it isolated, and then we'll deal with it. Okay, so I'm doing the manual refactoring pattern. Again, Martin Fowler's refactoring book has that. And I've got prototype and right-hand side. So normally I would expect that when I extract method that Xcode will come back and tell me, hey, you need to pass in prototype and right-hand side. All right, so let's pass those in. Prototype, I think that's list of variables. Oops, what's your type? Yeah, list of variables. And right-hand side is probably an expression. Yeah. And I'm not going to make myself put the names since they're different types. I'm not too worried. All right. And then what's new RHS, because that's what we're trying to return. That's also an expression. Okay. So what I have at this point is I believe I've extracted this and taken into account its arguments and its return values. And that's all we ask of these things, although I will return it. Okay, so I think I've got the right form of this thing. Now I got to kind of ask myself, what does it do, and can I call it? Well, let's call it first. So let new RHS equal foo of prototype and RHS, and then this stuff can hide for a moment, and that should all pass if I've done my extract right. And I don't see what was in there that Xcode just couldn't handle, really. But okay. All right, and now we want to ask what should be the name of this thing? What is it doing? Well, it's taking our function prototype, which is our list of variables, and it's taking the expression, and basically it's going to turn an in-argument function into a n times nested lambda expression. So if I have function a equals something on the right, or function x equals something on the right, then I want it to return lambda x, whatever was on the right, okay, the right-hand side, which is value, which is starts out as RHS. Okay, if I have two arguments, function of xy equals right-hand side, I want it to return lambda expression x goes to lambda expression, or lambda expression x is the variable. The value is lambda expression y goes to right-hand side. So that's what this thing is basically doing. The drop first is because that's the outside function name. So function AB or function XY, we don't need the function. We just need the arguments. So we want them to come out with the innermost in, the rightmost variable being on the innermost lambda expression. That's why it's reversed. And then reduce basically builds up lambda expressions from those things. So I think what we're doing is we are building, how about this is lambda expression from function prototype. Okay, and let's see how that reads up here. Well, right hand side is okay. This could probably be lambda, right? Something like that. Lambda expression. Let's rename that. Okay. So you get the location, you pre-declare the function, you parse the right-hand side, and then you turn the prototype in the right-hand side into a lambda expression, and you plop that in as the definition of this thing. That's definitely better. I'm liking it. Now I'm going to move this down because I try and get things more or less in the order they're called, more or less top to bottom. So that will go down here. Okay. Yeah, and that's much more at a single level of discourse. The location thing, okay, get the token a little bit. Figure out the prototype, parse the right hand side, build a lambda expression from it, and then wrap the whole thing in a definition, and that's what you return. That is good. It's a little crowded, it's a little long, but I think it's expressing both the parsing and the semantics, and each of the semantics is at most aligned. So I'm okay. All right, let's see how this is looking. Prototype, enforce prototype is all variables. this is another. Well, you got to decide if we're what level we're at, but prototype drop first, reduce to generic. I mean, this is basically forming a generic to generic to generic function. Can we push this to Elm type? I'll bet we can. I guess I'm imagining something that's a function. I don't know. What I was imagining was calling Elm type dot make function 3 comma generic, something like that, and that would make generic goes to generic goes to generic, or generic goes generic to generic generic. Tough to say. It might help. I mean, the interesting thing is you're wrapping it n times. I don't know. We'll save that thought. Okay. Now this one, left-hand side. If it's a function call, get the expressions out. Otherwise, get just the list of the left-hand side, which could be a variable. If it's not all variables, throw an error and map this to force it to all variables. Okay, yeah, this one is all variables is Boolean. There might be another way to do this. Well, one thing is, this is a little awkward. Maybe conceiving it as function call is premature earlier. This function prototypes all satisfy variable. I almost could. Function prototype is a list. What's the one? If I do a filter, can I get it? That's what I'm thinking is left-hand side variables is let me try a different way then. So I think I'm going to say let just variables equal function prototype dot filter $0 is variable. All right, and I think that'll give me a list of just variables. Expressions. There's another one that gets rid of nils. Let's see. Swift filter. It's not filter. Interesting. Language. I don't want filter, but I want something that I want it to get. Is it compact map? Yeah. I think I can do this one. So it returns the non-nil results. All right. So compact map $0 as variable. Okay. I think this one will do that. Yes. Okay. So instead of checking them and then converting them, I'm just going to say get the variables. And then the error condition is if, well, I'll do it down here. Let me copy this line or comment. If function prototype dot count not equal just variables dot count. All right, then I violated that the function call has no variables. All right, so let me comment out what I think is dead. Just make sure this works. And then I got to return just variables. All right, so I don't know. This is no formal official refactoring. It's me kind of trying to find a better path through the streaming and all that stuff. So I do expect it to have the exact same semantics, though. Now they upgraded Xcode, or I upgraded Xcode, accepted the upgrade, and they said it would compile faster incrementally, but I'm not seeing it. All right, let's take this out and see what's left. Okay, if function prototypes, we get the list, we pull out the variables, and we get back the list of variables. Well, is this enforce anymore? I don't know if that's the right word. Try prototype equals. I think I'm just going to call it function prototype variables and let it enforce as a side effect. Okay. All right, try function prototype variables. Prototype equals the function prototype variables. Yeah, that seems okay. Drop first. Yeah, I just want to push this somewhere else. I mean, everything about this, it really is just the count. I just don't know if it's a useful enough function. It's returning this wrapped thing. If it's one variable, no, if it's 0, return generic. If it's 1, return a function of. I think we can do it. Let's rework it in place here. Well, actually, I say we've been going for a while. Let's take a break. We'll take a 2 or 3 minute break, and then we'll come back and convert this to. We'll extract out the pieces so we can create a method that just works on the count. And hopefully, again, I'm trying to get this method composed so everything is sort of the same level. So, yeah, 2 or 3 minutes. See you then. Welcome back. All right, let's see. Let me commit this while we're still there. So we basically we refactor. I'll just say refactor to composed method, and let it go there. All right. So where I left off, I was saying I want to make this a function of the count. All right, so I don't think I can extract a variable. I can, yay. I never know when. All right, I don't really care what this is. This is well, I'm going to get rid of this variable, so I'm just going to call it prototype stuff and let it go for now. All right, so I'm iterating through that. For each value, for 0, I do this. So I want to do a count, and then I want to do 0 dot count, and well, this equal that. Okay. And then let's see if that does its thing. It's a little weird. Well, if it works, I'm going to get rid of the drop first and just add 1 and call it a day. Does not work. Okay. That'll teach me. Definition n function call variable to a is not the same as definition lambda n. A goes to a. Okay, what is going on? Let's. Okay, I don't know how much to think it through and how much to just do it. 0 dot count should be generic. Let's put it back. Okay, that should work. And I don't care about the type, but I do care about the. So if prototype is an empty list. Well, no, it can't be an empty list. It's got to be 1. Prototype stuff could be 0. And if I call prototype stuff.reduce on 0, I don't know if I'm making a. Let's try this. 0 dot less than prototype stuff dot count. And I'm going to take off the drop first. Are you kidding me? So I should go through 0 and get generic, and then through the rest, I think. Well, so my theory of this is not coming out too good, is it? Let's see, is that the same failure? A just came back A. Function called lambda n. So prototype count should be 1, 0.1. I don't know, maybe I'm wasting my time with the reduce. What I really was anticipating, let me put it back to the original. That should be fine. I'm just going to do the replace algorithm refactoring and see if I can make that go. So I'm saying we are only iterating through the list of functions. Okay. So I think I'm going to say let the or variable the type equals elm type dot generic. If I go 0 dot dot less than prototype dot count and the type equals this, instead of value I put the type. Okay. Cannot call values dot for each. I don't know. Sometimes an old-fashioned loop would just be fine. Let's pass back the type. So we got both calculated. Oh, come on. I may be off by 1 here still. Yeah, I feel like I'm off by 1 because if prototype just has the function definition, it should return generic. But I'm going to... function call generic function type. Definition lambda and function call variable function variable n goes to a. I don't know. I can never tell which is the expected and which is the actual anymore because they're expected a. Function call variable function n of a. Is that the expected? I don't think it is. All right, I'm gonna stop and look. Maybe this is not an equivalence, and I'm just fighting the tide. Let's just run one test, shall we? This one. Now that one failed for more reasons. I guess this must be the actual. It should be taking me to that breakpoint someday here. There we go. Okay, so let's look at the type. Generic goes to generic goes to generic. And let's look at the prototype. Function n. Okay, that's definitely too many. Let's start here. Yeah, okay. If it just has function, which is x equals 3 kind of thing, x equals 3 should get the type elm type dot generic. well, and then eventually it turns into the number that it is. But by default, generic. Okay, I'll just... So we're kind of skipping over the function definition and taking any other prototypes. If the count is 2, got function end, we should just do 1 and do 1 wrapper, I think. Okay. Ugh. So this goes away. And that should be good as it stands. Now, let's get it over to Elm type. And I'm going to extract this as a variable because I want to extract stuff I don't want to move into outside the scope of what I'm doing. So extract variable. I'll just say count. I'll move it out of the way because it doesn't interact. All right, now this, I can extract a method. Oh, come on. We'll do it manually again. I'll delete that breakpoint. The method is function I don't know, wrap generic function. It's not generic function. Wrap function type. That. Okay. And it returns the type. Count must come in. And the return type is an Elm type. Okay. Unexpected non-void return in void function. I'll let you wake up a little bit there. I think that should be okay. All right. Unexpected non-void type in void function. Non-void type in void function. I said Elm type here. Okay, what's the issue? Oh, am I missing something? Yes, I am. As is so often the case. Okay. No such overwhelm. That brace. That brace. Like, what the heck? Attribute file private. What's my diff? Okay, is that an actual? I don't know how that got down there. I'll just try a build. What the heck? Input tests. Why would you be complaining after all this time? No such module Whelm. Well, it's right here. Oh, I didn't rebuild the test. Build just builds the file. Find my little function. Okay. And actually, I want to pass in generic too. I might be able to use this elsewhere with that. We'll call it a base type of Elm type, and okay, and now I should be able to call this thing the type equals wrap function type. The count is prototype.count. The base type is elm type.generic. That should replace these 3 lines. Whoops. And just work. Now, I don't know if I should maybe that one dot count is a little weird to me. I'm also going to change this to result. Okay, so that's a pretty simple wrapper. Well, one thing that can certainly be true is this could be moved over to Elm type at this point. But this count bugs me. I really want it to be the parameter count. Let's try that. Let's make this parameter count. Oops. And so I'm saying it should be this and the prototype count -1 because it's got the function name as well. I think that should be equivalent. Variable the type was never. Oh, yeah, okay. Unfortunately, we know it catches it twice if it gets the count off by 1. Okay, so we'll let this can go. This can go. Okay, so now we're at least at that kind of composed level. Let's move this over to Elm type. I'll just copy it for now. Extension. It's kind of like these function ones. So let's do this. Static Elm type wrap function type parameter count and the base type, is that the right name? I'll live with it. Okay, and then over here we should be able to call Elm type dot that and take this out. So this is a move method that's sort of a static method, so I'm hopeful that we are good. Excuse me. All right. So we simplified whatever that pretty clear function to allow recursion by extracting part and moving it to Elm type dot wrap function type. All right. And again, I'm just trying to get things to consistent levels of discourse. That seems fine. And also, we could see that a lot of the stuff going on there was all around types and not around our stuff. So let's move stuff to the right place. This one still bugs me a little, that we have to do the work to either get one or the other, but okay. This is kind of a low level thing. I'm just going to say return this. I'm going to try to say return this, and then I don't need that. Prototype, drop first, reversed, reduce. And this lambda expression. Okay, upper expression. Mostly okay. Now this one's interesting. Here's the place where we make that trouble for ourselves. Express count equals 1, return express 0, otherwise return function call. And then up above we say, oh, if the count is, if it's one thing, plug it in as an array of one thing, otherwise pull the stuff out of the function call. That again makes me wonder, like somebody's going to have to do this because we do treat a simple expression different than a function call. If you just say 7, we just want to get the 7 and pass it back. We don't want to pretend it's a function call of 0 arguments. But there's something going on there. Now this is kind of the bottom level of expression where it's got to figure out which kind of expression are you. So you're an integer, float, and so on. Variable, yeah, that's all consistent. This is pretty reasonable. This stuff at the end, I think I could extract. Types, tuple. Well, he's returning error expressions. I guess he's returning the thing he wants to build. Yeah. Okay, so this, I think, is a method. I'm going to say extract, and it's going to say I can't. Oh, it's going to this time. I just can't tell. And I'm going to leave it for a moment. End result. Puts it above. Extracted function result is a list. It does modify result? That doesn't seem right. We map result, we count result, we make a tuple out of result. I don't think we need to do in out on this. Failed, huh? Oh, I don't need the ampersand anymore. Okay. What's the name of this thing? So it is the, well, basically it's either returning a result or a tuple. I don't know. Results or tuple is an awkward name. Maybe wrap tuple. We don't really treat a one argument thing as a tuple. So if you do parenthesis one parenthesis, it's just integer one. We don't want to mess with calling it a single tuple, a monuple, or whatever you would call it, uniuple. I don't know if I call it wrap tuple. I guess I can make that'll be a somewhat better name. And again, I'm going to move this down. I don't know why they want to tell the story backwards. To me, you want to tell it top to bottom, but things vary. Okay, result. Let's rename that. So this is the well, even expressions would be better. Let's try that. We're going to build up the type. If it's, well, this is only used here, we can get a little breathing room. Okay. Wrap potential tuple. I don't know what we call this. I mean, I'll live with this. Okay, but I think, again, this is a little big-ish, but gets it done. Require. So it's parse error.error. If statement. Am I in the wrong? Yeah, we were looking at tuple. Boy, anything at this point gets error message right parenthesis. That just doesn't. Oh, we do require that. Okay, so that's on us. Anybody else, they've already wrapped it up. Sorry, if the left and then or else were missing from inside, it would be dealt with, I guess. Even. Okay, and same thing down here. Errors then or else. We're not looking for anything requiring anything other than those two. So, yeah. All right. All right. I think that will get us through. Okay. The build seems slower to me. I don't know. I should pull up the video and find out. All right, but this is, I don't know. Whoops. Let's see. We did the land. Well, I guess mostly we extracted refactor, extract wrap tuple. Okay. So I'm reasonably content. Well, I'm certainly much happier than I was when we started the day. How's that? Even if I'm not perfectly content. But I think the next thing, let's see what we got here. Consider throws better than that. Okay, we've done that. That's all part of function calls. Today's 28th, 21, episode 50. Woohoo! This was refactor, especially error handling. And the story is function call. And we did this. All right. Test tuple, get extra comma. I think before that, what's this story? This story I'm talking about is something like custom values. Support custom values, but you know. All right. And the issue is put bool, false, and true in the symbol table. Okay. That's we're changing gears for sure on that. Okay. So bool, false, and true in the symbol table, right? Okay, right now bool type is a custom type, and the way we handle custom types right now is you've got the type name, and then these are called, I think, the variants, false and true, and then we also have the names. We go both ways, so the false maps to the bool type and true maps to the bool type. So given a type, you can tell what names are in it. Given a name, you can tell what type it is. A mutual dependency, yay. Okay. And this table basically maps each one to the type it is. And that's okay. So I'd like it to be in the symbol table, like we put the prefix operator primitives. I would like to add those types. The mapping for these. Okay, so I could do that. Let's see. Is this a refactoring? So I think it is. Basically, we're looking in predefined custom types. Let's see who uses that. One place, I think, yes. Okay, so here we look up the custom types in the custom type table. It's really custom type variants or custom variants or something like that. Let's change that. I'll say custom type variants. Okay. So what I would like to see happen is if you don't find it there, then you should look in the symbol table. And let's see what symbol table does. All right, and I'm curious, when you ask for it, you get an expression optional. So it does the right kind of thing. Okay, so I'm saying if you don't find it in there, then you should look in the symbol table for the name. Otherwise, you should get an error. All right. Elm type, to expected argument type expression. Oh, is this an expression? Oh, type 4. I guess we want type 4. Symbol table.type for name gives us an Elm type. All right, let's do that. Symbol table.type for type 4 name. Okay. Oh, that's interesting. If we don't know it, we say generic. Well, let's see if it happens. I don't know if it enforces this or not. If you look up a variant and you don't get it, the other is if you don't find a name, let's see, from the symbol table point of view, if you don't find a type if you don't find a name in there, you just say generic. Okay, so somebody is checking. That's probably a good thing. Unknown custom value should be an error. Okay. Right. Let's put this back. Type.error, and I'm gonna do that. Now type is always Elm type. I think Elm type has an error type on it that I could use. Yeah. Okay. Let's try that here and see who relies on generic. So this is exploratory, I guess you'd say. I'm considering a modification and seeing the implications, and then we'll decide whether or not we prefer it that way. But we're kind of stacking things up. We were working on the parser, how it looks up variants, and now we're stacking up and looking at how the symbol table does it. And lots of people seem to care. Okay, so let's see what happens. Let's do an Elm REPL. Unknown name. What happens? I can't find it. Okay. I'm thinking we might be okay the other way. This generic is reasonable enough. It's saying if you don't know a name, accept it as generic, which I don't think is going to hurt, because I think somebody will still, somebody will still complain if the name is unknown. I don't know what we do. Maybe that's the real question. Okay. So let's go over here. Come on, this program isn't that big. Okay, so if I do a name, well, let's do false. We know that one. False is Boolean. All right, let's do random unknown. We don't know that one. Custom value, unknown custom value. Okay. Let's see if we can. Let's go this way again. Okay, so symbol table always, whoops. Oh. Symbol table always returns a type. It'll return generic if it fails. Custom types used to return error, so there was one place. Let's see if we really care about the type. I don't care about the type if it catches the name being wrong. So let's see if we can change that behavior. And I think, well, we'll see what the test does, but I think if we ran it, maybe it would come back, instead of error on the right, it would say generic. I can definitely live with that. Okay, let's run. I'm puzzled why it takes so long. There's just like nothing going on. All right, but this was Mr. Random Unknown. I can definitely live with that. Oh no, it should be an error. It should be an error of some sort. Let's see. What's the complaint here? Basically, it was like I got no error. I got unknown. Well, this is evaluating. All right, so that's definitely returns that. Let's go to the evaluation of these custom values. Well, when we evaluate you, we don't even look for it. We just say it's an error. Okay, I may not be able to change this as quickly as I wanted. Let's drop that. Eventually I want to do symbol table.name, but somewhere, yeah, let's push on the other side for a while. Let's try and get these types in the symbol table. I would like that. Okay, so if I did symbol table dot add Boolean, and then this is the type, right? No. Oh, it's Maybe the type's not the one to start with. The type doesn't need to be in the symbol table yet. We just have predefined. You can't really say anything about bool yet. You get it as a result, but you don't create your own declarations about bool. So for now, we don't have to worry about that. But I would like to add this. I think he's a custom value. We should be able to say the string name and the type. Okay, custom value of false, and his type is bool type. Okay, that should be there. Add true. Okay. That shouldn't create any issues. Now, what's weird to me is, like, when I evaluate these things, they normally evaluate to themselves. But we're using the names like they don't matter. Let's find down at the bottom here in expressions, lowercase name, uppercase name, get token. If look up the custom value, if the type is error, return an error expression, otherwise wrap it in a custom value. Maybe this thing, look up custom value, maybe should return a custom value. But why do we care about the type? That's just so we can get to the custom value. Look up custom value. If it doesn't find it, well, it returns error if it doesn't find it. And if this were looking in the symbol table and it didn't find it, it would be returning a nil. Yeah, let's... All right. What I'm tempted to do is make lookup custom value, return a custom value for the thing it finds. So it's not returning a type. It's going to return either an error expression. Location is randomly out there. That's a little weird. We can wrap it on the way back if we need to, so that's okay. But let's make lookup custom value return this stuff. Okay, so we're going to move this into lookup custom value. One way to do that, because we saw this was the only place, is inline it, which we have to do manually. Well, really, I'm trying to inject this. I'm trying to say return. Well, I'm trying to. Excuse me. I'm trying to inject this stuff into lookup custom value. Let's find that thing. Are you down here? Okay. So if let's do that. Okay, we'll paste that there. So that's part of what we're doing. We're saying we don't want to return Elm type. We want to return expression. Okay, and if let the variant equal this. Okay, it's if the variant is elm type.error, then this else custom value name and variant. Maybe this is variant type. Yeah. Maybe it's just the type. Oops. Okay, and then go find where it's used again. And we're just going to say return this. And if we've done this right, that just works. All right. We'll let that go. I think we're due for a break. We've been going a while. We'll wait the 2 seconds. Come on. I love how it takes 12 seconds and tell you it's 1.6. So 2 or 3 minutes. Welcome back. All right, so we've got this thing returning error expression otherwise. I kind of see what symbol table does. Symbol table is ruling to return an empty. All right, so I'm gonna make a judgment call here that we should pass in the location, and the type of location is, yeah, of course, it's just int. I think location. Yes, location, of course. Let's find our predefined. Yeah. Okay, and this should take a location. Okay. I'm trying to get it a little more independent so that its arguments drive the work. All right, now I don't care about the type. Okay, I'm gonna modify this. Well, okay, so first thing we've done is we did refactor, we rearranged, we sort of did a, well, pull and tail code to probably that I can't remember the name is a sign that the name is not a good name, but look up custom value. So that's the big thing we did. So it's sort of the equivalent of inline extract method on the existing plus some new stuff, and then that gives the effect of pulling the tailcode in. We did it manually. Okay, so we'll commit that. All right, now we're going to work on lookup custom values. So really we're after types. Okay, so let's say if this not equal nil, we can do a let. Okay, so if let predefined equal that. Okay, so it calls that. If it's not nil, then it's going to, we want to return this. And this is predefined. Okay. If it is an error, otherwise it's an error. If it came back nil, we want to treat it as error, and we're going to make this return type as sort of our else clause. Okay, so my claim is those 4 lines are equivalent to these 4-ish lines. Okay, so if we find that the predefined name exists, then we return a custom value with that type. The predefined is the type we're looking up. Otherwise, we return an error message with the unknown custom value and the location. That should pass. So I'm pushing, I want to get custom values stuck in the predefined table originally. Okay. And we'll delete that. All right. Now, why am I calculating custom value every single time? Well, it would be nice if the table had it. Okay, so where's my predefined table? We know that's the only place touching it. All right. So we would like false to map to custom value false and bool type, and same thing for true. Maps to custom value true bool type. Okay. Now predefined constant variable. This is really expression. Okay, and then the use of it, if it's found, then we're just going to return predefined. Otherwise, we bail out with an error expression. Okay, so let's run. We should still have the same behavior we had for false and error, I think. So false should come back with the Boolean value, and unknown should come back with some sort of complaint. Own custom value in line 1, column 8. That's an error. All right, and that's a parsing error, which is probably the right kind of error. Okay, now I think we're ready to do a swap over. So I've got predefined custom type variants. I've got the same stuff added, or at least equivalent stuff added to the symbol table. All right, so I should be able to look those up in the symbol table, and I either get back the value or a nil. All right, let's look up. I guess hopefully I'm still searching for that. Yeah. Okay. So now if I did this, variant equal predefined symbol table subname. Okay. Then return variant, right? This should be fine. I mean, it never gets here because the variants are all in the custom type variants. So instead of just switching over, I've made the symbol table the backup for the real one. Assuming that passes, I'm going to comment out 90 through 92, and then tear out all the consequences from switching methods, switching approaches. Okay, so if this works, we're using the new way now. We're looking at the symbol table. So I kept both things running in parallel, basically. An old technique. But the difference is we never really tested the variant symbol table until now. So, all right, so that we've made that transformation. So if it's in the symbol table, return it. Otherwise, build up an error message with the location, which seems like the right thing. Okay, custom value. Yeah, that's probably a better name, right? The only way you can get there is if somebody puts you there. We don't have a way to put in uppercase names yet. And so, okay, so let's run this. We'll do it manually once, make sure. It's still behaving somehow. We'll mix it up. We'll try true. True should be true. And unknown should be some sort of error. Yes. Okay. What do we got? Location. Now, nobody should be referencing this for real use. Let's find usages. Oh, there's another way to do that. Caller. Yeah, the only place referencing that is here. Same here. Okay. So nobody uses this. Let's get rid of it. Nobody uses this, so let's get rid of that. Okay. Now we just have the symbol table. We've pre-populated the Boolean type and the values in the symbol table. Eventually, we would have to add the types to the symbol table because you can define new types. I don't know if you can override system types or not, but it's certainly theoretically possible they could have decided that. All right, now this looks good. All right, we'll commit that. So we switched from a custom table to lookup in the symbol table for custom type variants. Yes. All right. To do, come on. How do I get back to do? These Xcode bugs that make me wonder if they ever looked at this. Like, did they not notice this usability issue? All right. And that can move up. Okay, so custom values, put false and true. Well, it's really just false and true in the symbol table. And it's really, lookup is really the interesting thing. Okay. Rather than a separate table. Yep. Okay. So I think that gets us through what I wanted to today. I'm not going to stop here, but just saying that we did a fair bit of work in the parser, just kind of general cleanup, and we got these custom values straightened out. So I think that's a good level. Now we can look at this. Future test tuple. All right, so parser tests. Let's find the future. Test tuple generation. All right. Let's take the future off. Three, 4. Yeah, that should get some sort of error. Function call must have function. Yeah, that might be the error we should get. Because the way it is now, it's got operator expression goes to function call expression, which is expressions, and then it goes down to the level where it will catch the tuple. A non-function cannot be called is not equal to function call error. Well, that makes me wonder. Let's block that one for a minute. let's simplify the problem. Let's just see what you get for this. Oh, come on. Well, I'll duplicate that. Test missing operator looks like function call. Take off the parentheses. I have no idea what the real error is going to be, but let's just run it. Okay. Well, I don't know whether to be happy or not. Hey, we got our error things back. Okay, good. An error non-function cannot be called is not equal to function call error. All right, so there's something in our function parsing that's still not quite right. Function caller definition. All right, so it calls operator expression, which is down here. Operator expression, it calls expression 3.0. It calls expressions. Okay, so expression gets 3.0. While you can start an expression, 4.0 can certainly start an expression. Get an expression. Okay. If there are two, it's a function call. Oh, we've missed a case here. Basically, the type of the first one has to be, if the count is 1, yeah, you can just return it. But if it's more than 1, it's not really a function call. If it's something like 3.0, it's got to be a name of some sort. Or a lambda. If the first expression is not a functional kind of thing. Oh, we left that. Right. In our grammar, I mean, you can call lambda n, parenthesis lambda n goes to n, applied to 4.0. That's a perfectly valid function. So we should allow lambda expression. We should allow lowercase name. I don't think there's anything else that we would allow there. Okay. So if anything's an error expression, then we want to stop. Okay. If expressions.count is 1, then we just want to return expression sub 0. That's the first one. All right. Otherwise, if expression sub 0 dot something, I don't know, is well, it can be lowercase name. What do we do for that? As a variable. Or it's a lambda. Then we're going to return the function calls. Otherwise, we're going to return some sort of error. Function call must have function with the location. All right. That should pass our test. I may have forgotten some possibility, I guess. Okay, and let me just check that we really do test this case. I want to make sure that we've got at least one example where the lambda expression applies. This should fail, I hope. If it doesn't fail, my tests aren't sufficient for this problem. Okay, that's good. Variable, I don't think we can miss because that's the normal function call stuff. Okay. Back to our tests. So this test, missing operator looks like a function call. Let's put that in the function section. Function call, bad argument. Yeah, that's kind of like that. Oops. And now test parenthesized, that is an example of the lambda expression called to there. Okay. Is that the right thing to look at? Well, this should pass now. No, what do we got? Oh, column number. Okay, I'm all right with that. 1, 2, 3, 4, 5, 6, 7. We realize that the parentheses. Yeah, that's okay. What's giving me pause right now? It's like I don't know if I should be looking. Actually, I don't think I should be looking at the this. I think I should be looking at its type. Let's try that. If expr sub 0 dot type. Can I do that? Better on the left hand side. Okay. Let dot function of nothing equal this. Okay. If case a function has no effect. Well, it. Oh, okay. Do I not need the let? Okay. If the type of the expression is function, return a function call. That's better than type checking these things. All right. So let's see if this works. Maybe the simulator's just gotten so slow. It's on 14.5 now. I don't know, maybe I could back it up a little. Oh, everybody fails. Okay, what are you saying? Oh, yeah. Because we can't assert anything until we get there. Like, yeah. Okay. I would have preferred the other way, but let's revert this. Is variable over that. Oops. Right, because the type is still undefined when you're defining it. I mean, I could accept function or undefined. All right, let's see. Are we? Yeah, we are modified. Okay, so check that first has an actual function first. Okay. Let's try that again. Boy, it really is. If it's a variable, I'm going to try it this way. Oh no, I have to do the case let thing. I don't think there's a good way to get the type of that thing without. All right. Maybe, can I switch on it? One case is function. We're going to return this. Default, we're going to return this. And otherwise, I think if you're an error, well, it's undefined. Oh, I gotta say comma. Function type or error return function call. These things go away. Now, I expect less than 8 or 10 failures. There may still be some, but I'm going to have to figure out what an undefined name looks like, I guess. Because if you say function XY, it could be a function, it could be a definition coming up. All right, 5 failures. That may be plausible. What does it come back with? Non-function cannot be called in line 1. That should be legal. Okay, so we don't know the type of function yet. Yeah, all these things have... Well, that's a little funny. Okay, let's get back to parser. What are my choices? Dot. It could be unknown. I'm not sure where I'm. Let's find where we parse variables and see what happens. Lowercase name variable symbol table for type for name. So it could be generic as well. Yeah, I think generic is what we really want here. And if it's an error, I'm okay to return. There's nothing special about that one. All right, let's try that. What do we have for failures before? I can't remember. 5? Hopefully it's 0 if I've got the right thing here. Because you have to define a function, we say generic by default. All right. I think that's an improvement. And maybe this we'll make a wrap function call, kind of similar to the ones we had before, wrap function call. And these are all kind of trying to figure out the return types of stuff. All right, we know we need expers. Is a list of expression. Return type is expression. All right, if there's only one, we return it. Otherwise, we look at its type of the first one. If it's a function or generic, then we return function call. Otherwise, we say, no, it really must be some sort of error. All right, and then I think I can just call it here. Return wrap function call with expressions instead of all this. I will take the chance and do that. I'm hoping everything passes and we can just call it a wrap, as it were. Okay, we extracted. Well, we made functions check first argument to be a function. Extracted wrap function call. All right, and that we can update that. Let's see. How do we want to say this? How about properly detect when a function call doesn't have a function as the first expression. Okay, and let's take that down here. That is fine. All right. So I think we're at a reasonable stopping point. I'd just take a look at what we have possibly coming up and see what we want to tackle. I think next time I'm trying to wrap this thing up. So we're not going to finish the whole interpreter. We got maybe, I don't know, a third. Maybe it's a little more, but it's not more than half, I don't think. But we've got some chunk of the interpreter done. I'm not completely satisfied with our type checking, which is a pity, but I really don't have anything that tells me like exactly what it means semantically, so I kind of have to derive it myself, and I'm not so interested in doing that, I guess. We do have calculations on numbers with recursion, so you have at least some theoretical, reasonable set of things. I think what I'll do is just pick one or maybe two more of these things that we've noticed that are missing, something simple, and then maybe spend the last bit just kind of walk through and see what we have across the whole system and what we're happy with and not happy with and that kind of thing. So, first hour will work and the second hour we'll review, I guess. But anyway, thanks for joining me today. Hope you can join me in the future. Next time is tomorrow, Thursday, 1 to 3 p.m. Eastern Time. Bye-bye.